Hello everyone. Today we will discuss about carbon and its compounds. In that, hydrocarbons. What are the different types of hydrocarbons? How do we classify? Here hydrocarbons are of two types. One is saturated hydrocarbons and other is unsaturated hydrocarbons. Saturated and unsaturated. Again, saturated are only alkanes, but unsaturated are of two types, alkenes and alkynes. When do we say that a hydrocarbon is saturated? If there is a single covalent bond between carbon and carbon atoms. If there is a single covalent bond between carbon and carbon atoms, we call it as saturated hydrocarbon. In saturated hydrocarbon, they will be called as alkanes. Then when do we say that the hydrocarbons are unsaturated hydrocarbons? If there is a double bond between carbon and carbon or a triple bond between carbon and carbon. So if only single bond is there, saturated, double bond or triple bond are there, then they will be called as unsaturated. Again in that, if there is double bond between carbon and carbon, if there is double bond between carbon and carbon, we call them alkenes. Similarly, if triple bond is present between carbon and carbon, we call them alkynes. If triple bond is there, we call them alkynes. So hydrocarbons are of two types, saturated and unsaturated. If there is a single covalent bond between carbon and carbon, it will be called as saturated hydrocarbon, and in that it will be called alkane. If there is a double bond or triple bond, we call it as unsaturated hydrocarbon. If there is double bond, we call it as alkene. If there is triple bond between carbon and carbon, we call it as alkynes. So like this, we have to remember types of hydrocarbons in carbon and its compounds. Now here, how do we write molecular formulae of alkanes, alkenes, alkynes? Or when a hydrocarbon is given, how do we identify whether it is saturated or unsaturated? Again, in unsaturated also, whether it is alkene or alkyne. So we need to remember here one general formula to classify these by seeing the molecular formula. Here general formula is what? For alkanes, general formula is Cn H2n plus 2. For alkenes, general formula is Cn H2n. For alkynes, general formula is Cn H2n minus 2. Or simply you can remember like this. For alkanes, so how many number of carbons are there? For example, we have one carbon, then double the number of carbons, that is 2. So 2 hydrogens plus 2. So in alkanes, 2 hydrogens will be more than the double the carbon atoms. One more example let us see to understand. For example, there are 2 carbon atoms. Then what is the double twice 2? 2 times of 2, that is 4. So CH 4 plus 2. So every time after we are doubling, we have to add 2 to it, so that we get alkanes. So what? Simply C1 if it is there, then H2 plus 2 4. C2 if it is there, H4 plus 2 6. C3 if it is there, double is 6 plus 2 8. C4 if it is there, double it 8 plus 2 10. C5 if it is there, double it, then plus add 2, that is 12. C6 if it is there, double is 12, add 2 14. C7 if it is there, double it, 14 plus 2 16. C8 if it is there, double is 16 plus 2 18. So like this, all these are molecular formula of alkanes. So how do we identify when a structure, when molecular formula is given, whether it is alkane or not? Just see the number of carbons and number of hydrogens. If number of hydrogens are 2 more than double the number of carbons, then we decide it as alkene. Then what about alkene? In alkene, exactly double. Hydrogen atoms will be exactly double the number of carbons. For example, there will be no alkene with one carbon. We have to remember it. There will be no one carbon. There will be no alkene or alkyne with one carbon. So what is the first alkene that starts? Minimum number of carbon atoms in alkenes is 2. Minimum number of carbon atoms in alkynes also 2. This is very important point we have to remember. So from 2 onwards we have to start. If there are 2 carbon atoms, then exactly double the number of hydrogens will be double it. So C2H4. If there are 3 carbon atoms, double the number of carbon, that is 3 2 is 6, C3H6. C4, hope you understood it. How to write the molecular formula of alkene? C4H8, C5H10, C6H12, C7H14, C8H16. In this way we can write alkenes. Then what about alkynes? Alkynes also with first one carbon we cannot write. From 2 carbons onwards we have to start. In alkynes, what happens? Number of hydrogens will be 2 less than the double. In alkenes, 2 more than the double. In alkenes, exactly double. In alkynes, 2 less than the double. So for example, if you have 2 carbons, double is 4, then 2 subtract from 4, then we get H2. This is what? Alkyne. Then again C3, double it 6, subtract 2, 4, C3H4. C4, double it, it is 8, subtract 2, 6. C5, double is 10, subtract 2, becomes C5H8. Then C6, 12 minus 2, 10. C7, 14 minus 2, 12. C8, 16 minus 2, 14. So in this way we will write the molecular formula of alkanes, alkenes, alkynes. Hope you understood this. Now depends on the number of carbons present in the molecule or the compound, we give name to the hydrocarbon. Here these terms we have to remember, very important. If there is one carbon, we give there will be a sound meth. If it is alkane, we call it as methane. Methane. Oh, sorry, I wrote it as wrong. If it is alkane, we call it as methane. So if there is one carbon, meth sound will come, meth sound will come. If there are 2 carbons, eth, then this will become ethane. This will become ethene. Ethene. 2 carbons eth, and because it is alkene, ethene. Then 2 carbons eth, and because it is alkyne, will become ethyne. Then if there are 4 carbons, if there are 3 carbons, there will be prop prefix. So this will be what? Propane. This will be propene. And this will be propine. Similar way, if there are 4 carbons, we call it as bute. Bute, and this will be butane. This will be butene, butene. This will be butine. Similarly, if there are 5 carbons, we give name it as pent. Prefix will be pent, and the alkane will be pentane, and the alkene is pentene, and the alkyne is pentyne. Similarly, if there are 6 carbons, the word prefix is hex. Then here it will be hexane. This will be hexene, and this will be hexine. If there are 7, the prefix will be hept. Then this will be heptane. Heptane, heptene, heptine. Then if there are 8 carbons, oct sound will come, so it is octane, octene, and octine. So this is about hydrocarbons, saturated hydrocarbons and unsaturated hydrocarbons, alkenes, alkenes, alkynes, and their molecular formulae and the names. Now let us see how do we draw the structures of these hydrocarbons. For example, let us see the first one, alkanes with one hydrogen, one carbon, that is CH4. Then there will be one carbon atom in this. There will be only one carbon atom in this. Only one carbon atom, but 4 hydrogens. 1, 2. This is the structure of methane. What is the name? Because there is one carbon, it is methane. I told you there will be no methane and no methyl. Now with 2 carbon atoms, will be having molecular formula C2, because it is alkane, C2, H2, H4 plus 2. H4 plus 2 is 6. And the structure of it will be, there will be 2 carbon atoms. Between 2 carbon atoms, a single covalent bond will be there because it is alkane. And then because the valency of carbon is 4, there should be 4 bonds around carbon. Already 1 is over, 3 more bonds should be there. So those 3 more bonds will be there between carbon and first carbon and 3 hydrogens. Similarly, on the second carbon also, 1 is already over between carbon and carbon. So remaining 3 bonds will be there between carbon and hydrogen. This is the structure of C2H6. So here, this is what this will be called as ethane, because there are 2 carbon atoms, it is ethane. Next what we have, alkene. Methane is also there, methane is also present. So what is methane formula? C2H4, because exactly double, hydrogens should be exactly double. Now the structure will be, because there are 2 carbon atoms, carbon and carbon, 2 carbon atoms will be there. Now because it is alkene, there must be double bond between carbon and carbon. So this is what, double bond. Now around the first carbon, 4 bonds. Already 2 bonds are over, 2 more bonds should be there. 2 bonds are there between carbon and carbon. So one more bond between carbon and hydrogen, and similarly like that, like this, two bonds between carbon and two hydrogens. Similarly on the second carbon also two hydrogens. Now you can observe, for both the carbons are having four bonds around it, four covalent bonds around it. This is the structure of ethene. Ethene. Now alkyne, that is ethine. What is the formula of ethine? Two carbons, double four minus two, so two hydrogens. C2H2 is ethine, and its structure will be, between there should be two carbons, carbon and carbon, and between carbon and carbon there should be a triple bond. Because it is alkyne, there should be a triple bond, so we have to draw a triple bond. Already three bonds are over between carbon and carbon. There should be four bonds around the carbon. Already three are over, so one more will be there between carbon and hydrogen. Similarly on the second carbon also already three are over, one more will be there between carbon and hydrogen. This is the structure of ethine. Hope you understood this. Now, coming to the next, let us see one more. So by these examples, you may understand how to draw these structures. C3, how many hydrogen should be there? Double. 6 plus 2, 8. So C3H8. What it is? Propane. Propane formula is C3H8. Propane. Now propane structure, because there are three carbons, we have to draw three carbons and there should be a single bond between all the three carbons. Why? Because it is alkane. When it is alkane, there should be only single bonds between carbon and carbon. Okay, single bonds are over. Now around carbon there should be one hydrogen. There should be four bonds. Around carbon there should be four bonds. Already one bond is over between carbon and carbon for the first carbon. So three more bonds it can form between carbon and hydrogen. Now similarly, so the second one, if you observe second one, already two bonds are over between carbon and carbon, so it can form only two more bonds. Similarly, if you see third carbon, for third carbon there is only one bond is over, three more bonds can be drawn. Now if you observe, first here how many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8. And the number of carbons? 3. This is the structure of propane. Propane. Now propene. What is propene molecular formula? C3 exactly double H6. Structure how it will be? There should be three carbon atoms. 1, 2, 3. Three carbon atoms. There should be a double bond between only one first carbon and carbon. Then between second carbon and third carbon we'll draw a single bond, because it is propene. So here double bond and here single bond. Now for the first carbon already two bonds are over, two more bonds should be drawn. 1, 2. Second carbon already three bonds are over. One side, first side, left side 2, right side 1. There can be drawn only one hydrogen, one bond between carbon and hydrogen. We cannot draw one more because already four bonds are over. Now on the third carbon, again we can draw three hydrogens, because there is only one bond is finished as of now. So three more hydrogens. This is what? Propene. Propene. This is the structure of propene. Now C3H6 minus 2, 4. 6 minus 2, 4. What is this? Propyne. Now here how many carbon atoms again? 3 carbon atoms. 1, 2, 3. Between carbon and carbon, first carbon and second carbon, a triple bond, and the next a single bond. Now on the first carbon we can draw only one hydrogen because already four bonds are over. Because already three are over, only one hydrogen can be drawn. If you see the second bond, second carbon, here we have three, here we have one. 3 plus 1, 4. Already 4 bonds are done. So you cannot draw any hydrogen around it. Now when you come to third carbon, we can draw only one is over. So you can draw three more hydrogens. 1, 2, 3. This is what? Structure of propyne. 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 Last, let us try last one more structure, that is butane, butene, butine. C4 butane, C4 H8 plus 2 10. So there should be four carbons, 1, 2, 3, 4. On the first carbon we can draw three hydrogens. 1, 2, 3. On the second carbon we can draw only two hydrogens. On the third carbon we can draw two hydrogens because already 2 are over. Again on the fourth carbon we can draw three hydrogens because only one bond is over as of now. So like this C4H10 can be drawn, which is called butane. This is what? Butane. Butane is over. Now let us try butene. C4H8 exactly double C4H8. Now again like before we have to draw four carbons, 1, 2, 2, 3, 4. Between first carbon and second carbon we will draw a double bond, remaining single bonds. Now like on the first carbon already two bonds are over, so two more hydrogens. On the second carbon we have already three bonds over, so we can draw only one hydrogen here. Now four bonds are completed. Now coming to third carbon, here one, two are over. We have to draw two more hydrogens. 1, 2. Four bonds are over. Now on the fourth carbon we can draw three hydrogens to have four bonds around the carbon. So like this we can draw butene. This is what? Butene. Now butine, C4 8 minus 2, 8 minus 2 6, C4H6 it is. How many carbons? 4 carbons, so we have to draw 4 carbons. 1, 2, 3, 4. 4 carbons. On the first carbon, 4 carbons, and on the first carbon and second carbon will be having triple bond, not single bond. Triple bond. Why? Because it is a alkyne. Now on the first carbon we can draw only one hydrogen. On the second carbon we cannot draw any bond again because already four bonds are completed. On the third carbon we can draw two hydrogens like this. On the fourth carbon we can draw three hydrogens. This is the structure of butane. Hope you understood these structures also. It went up, table went up. Let us drag it down. So like this you can remember molecular formulae and the structures, which is very important in carbon and its compounds. So all these are very important. First you have to know general formula. If you go to the first slide, general formula is important. General formula is important. CnH2n plus 2. For alkanes, CnH2n exactly double. Alkenes, CnH2n minus 2. Alkynes. So already I told you about this molecular formulae, names and structures. Hope this will help you in your coming exams. Thank you.